Okay, this is lesson 4.4, and you should know that we're going to move things around a little bit. So we're actually going to do this problem second. So quickly, typically, you can write one equation based on one sentence, and you can write a second equation based on a second sentence. Oh my God, I spelled it so wrong. Second sentence. Okay, so we're going to go through that example and relate things from independent and dependent variables, but we're actually going to skip this one, and we're going to go on to this one first that says with a partner. Okay, so here we go. Let's just focus on the first sentence, and then we're going to pause after the first sentence and write equations like we did yesterday. So I actually don't even want to look at anything else until I'm done with that. So this says there are 2 more tigers than lions at the zoo. 2 more tells me plus 2. Okay. More tigers than lions, making tigers the dependent variable. How many tigers there are depends on how many lions there are. So I know that since tigers are dependent, it's going to be T equals. Now I knew that there were 2 more, so it's plus 2, and it's going to be how many lions there are, plus 2. So the next one, there are a total of 10 tigers and lions. A total of 10 tells me 10 equals of lions and tigers. So lions plus tigers equals 10. How many tigers are at the zoo? So what am I solving for? Number of tigers. So I'm going to go back and I'm going to quickly define my variables to make sure that I understand what they mean. So T was the number of tigers. And then L was the number of lions. Okay. So here's my system. I have 2 equations. The dependent variable was T, and so normally these are X and Y axes. And so my equations are normally Y equals X plus 2 or something like that. Y being my dependent variable. So instead of this being the y-axis, this is going to be the t-axis. Instead of this being the x-axis, it's going to be the l-axis. So coordinates that used to be x comma y will now be l comma t. So let's go ahead and graph our system. This has a y-intercept of 2, and the slope is 1 over 1. Rise 1, run 1. Go ahead and use a straight edge to connect the dots. This was equation 1. Equation 2 is currently not in slope-intercept form, so I'm going to rewrite it down here. And I'm going to go ahead and convert it into slope-intercept form, where I want the dependent variable by itself. So I need to isolate t, so I'll subtract L on both sides. So 10 minus L equals t. But maybe that doesn't make sense to me, so I'll flip it around. T equals, and I'll just put this same thing on the other side. And if you want your L to come first, just make sure you move the signs. T equals, this is a negative L, positive 10. This is equation 2. My y-intercept is 10. My slope is negative 1 over 1, down 1 over 1. Go ahead and draw a line using a straight edge. And as you see, the 2 lines intersect at that point, which is 1, 2, 3, 4, comma 1, 2, 3, 4, 5, 6. So since it's 4, 6, this tells me there are 4 lions and 6 tigers. Question was asking for how many tigers, so there are 6 tigers. So that's how you solve these types of problems, okay? I'm going to go back to this one. I'm just going to write the equations and scale it. I'm not actually going to graph it. So this says there are 12 more boys than girls in the classroom. I'm going to go ahead and I'm going to pause and write this equation. 12 more girls tells me plus 12, and girls is the dependent variable. So it'll be G equals boys in the classroom, B plus 12. Moving on, there are a total of 22 students. Total 22 students in the classroom. So 22 equals. Now the students that are in the classroom, those are boys and girls. So boys plus girls is 22. I have my system. Quickly define my variables. G equals number of girls. B equals number of boys. Okay, so what am I solving for? How many boys and how many girls? So boys and girls. Since girls is a dependent variable, I'm going to label my y-axis G. And then since boys is the independent variable, my x-axis becomes B. Now, if you look at the first equation, it has a 12 in it. So my y-intercept is going to be 12. But look at the second equation. Let's isolate G first. 22 equals B plus G. Subtract B. 22 minus B equals G. Flip it around. G equals, I'm going to write negative B first, plus 22. So my y-intercept is 22. That's really big. So what I'm actually going to do, I'm going to zoom in. I'm going to scale my axes by 2. So every line is going to be worth 2. And then anything in between, 12, 14, 16, 18, 20. Anything in between is a 1. So plotting the first equation, G equals B plus 12. My y-intercept is 12, and my slope is 1. I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So I've scaled my axes so that everything fits. The second equation has a y-intercept of 22. So I'm going to actually extend my graph. The slope is negative 1 over 1, down 1, right 1, down 1, right 1. So as you see, the lines still cross, but they cross in the middle of a box. 2, 4, 6. So this is at 5. And then it's at 16, 18, so 17. Again, this is B, comma G. So there are 5 boys and 17 girls. To see a complete solution, go ahead and check out the answer key.